September 15th, 1944, Schweinfurt, Germany. The air raid sirens wailed across the industrial city as Luftwaffe pilot Oberleutnant Klaus Weber scrambled toward his Messerschmitt 109. Through the dawn haze, he could see them approaching. Wave after wave of silver bombers stretching from horizon to horizon, their contrails painting geometric patterns across the German sky. Weber had been flying combat missions for 3 years, had witnessed the gradual escalation of Allied air power, but nothing had prepared him for what he saw that morning. As he climbed through 15,000 feet, Weber's radio crackled with reports from other pilots. The numbers seemed impossible. 600 B-17 flying fortresses, 400 B-24 Liberators, 800 escort fighters, over 1,800 aircraft in a single formation that extended for nearly 300 miles. Weber keyed his radio and transmitted words that would echo through German command centers for weeks. Mein Gott, there is no end to them. The entire sky belongs to America. What Weber witnessed that morning was not just another bombing raid. It was the culmination of the most extraordinary industrial mobilization in human history. An achievement so staggering that German military planners, even when presented with intelligence reports documenting American aircraft production, refused to believe the numbers. The mathematics seemed to defy logic. How could a nation fighting wars on multiple continents simultaneously produce aircraft at rates that exceeded Germany's wildest manufacturing dreams? The answer lay in a transformation so complete, so revolutionary, that it redefined what industrial warfare could achieve. This is the story of how America built an air force larger than the rest of the world combined, and how German pilots discovered they were fighting not just superior numbers, but a production miracle that rendered their own efforts meaningless. The revelation had begun 2 years earlier in the summer of 1942, when American aircraft production first caught German attention. Intelligence reports filtering back to Berlin spoke of impossible numbers. 4,000 aircraft per month rolling off American assembly lines. The figures were so outrageous that German production chief Albert Speer initially dismissed them as Allied propaganda. Germany, with its experienced workforce and advanced engineering, was struggling to produce 1,200 aircraft monthly. The idea that Americans, whom Nazi ideology portrayed as soft and inefficient, could outproduce German industry by such margins seemed absurd. Yet the evidence kept mounting. Captured American pilots carried documents referencing aircraft serial numbers that suggested production rates far beyond German comprehension. Luftwaffe reconnaissance flights over Britain photographed airfields packed with American-built aircraft in quantities that defied rational explanation. The truth was even more staggering than German intelligence suspected. By 1944, American aircraft production had reached levels that transformed the very nature of aerial warfare. The Willow Run plant outside Detroit was completing one B-24 Liberator bomber every 63 minutes. Republic Aviation was finishing a P-47 Thunderbolt fighter every 8 hours. North American Aviation was delivering P-51 Mustangs at rates that exceeded 1 per hour during peak production. These weren't just isolated factories achieving remarkable output. This was an entire continental manufacturing system operating at unprecedented efficiency. Across America, 66 major aircraft manufacturers employed over 2 million workers in a coordinated effort that dwarfed anything previously attempted in human history. The scale of American aircraft production became clear through statistics that German planners found impossible to accept. In 1944 alone, American factories delivered 96,318 aircraft to military forces. This single year's production exceeded Germany's total aircraft output for the entire war. The numbers told a story of industrial capacity so vast that it challenged fundamental assumptions about manufacturing limitations. Every month, American factories produced more aircraft than Germany managed in an entire quarter. Every week, American assembly lines delivered more planes than most nations built in a year. The production statistics revealed an industrial miracle that German engineers, despite their technical expertise, had never imagined possible. But raw numbers only told part of the story. The quality and sophistication of American aircraft production revealed technological advantages that German industry couldn't match. American factories employed assembly line techniques pioneered in automobile manufacturing, adapted for aircraft production with revolutionary results. The Boeing plant in Seattle used moving assembly lines that carried B-17 flying fortresses through 47 distinct production stations. Each worker performed specialized tasks with precision that ensured consistent quality across thousands of identical aircraft. This standardization allowed American forces to deploy massive numbers of aircraft with interchangeable parts, simplified maintenance, and standardized training procedures. German aircraft production, by contrast, remained largely artisanal. Each Messerschmitt or Focke-Wulf fighter required individual attention from skilled craftsmen who hand-fitted components and made adjustments throughout the manufacturing process. The human dimension of American aircraft production was equally impressive. By 1943, American aircraft factories employed more workers than the entire German aircraft industry had ever imagined necessary. The Consolidated Aircraft Plant in San Diego employed 45,000 workers producing B-24 bombers around the clock. Douglas Aircraft in Long Beach operated with 160,000 employees, building everything from transport aircraft to dive bombers. These weren't just workers transferred from other industries. America had trained an entirely new workforce specifically for aircraft production. Training programs graduated skilled aviation workers in weeks, rather than the years required for traditional apprenticeships. Women comprised nearly 40% of the aircraft manufacturing workforce, performing precision assembly work that German industry reserved exclusively for master craftsmen. The technological sophistication of American aircraft manufacturing extended beyond simple assembly line efficiency. American factories pioneered manufacturing techniques that revolutionized industrial production. Aluminum fabrication methods developed for aircraft construction employed precision tooling that could produce thousands of identical components with tolerances measured in thousandths of an inch. Welding techniques perfected in aircraft factories achieved strength and reliability standards that exceeded anything German industry had developed. Engine manufacturing reached levels of precision and consistency that allowed American aircraft to operate reliably in conditions that would ground German planes. The Pratt & Whitney factory in East Hartford produced aircraft engines with standardization so complete that components were interchangeable between engines built months apart in different facilities. Material procurement for American aircraft production revealed logistical capabilities that staggered German observers. Aluminum production alone required coordination between mining operations in multiple states, smelting facilities powered by massive hydroelectric projects, and transportation networks that moved raw materials across continental distances. The Alcoa aluminum plants consumed more electricity than entire European nations, powered by dams constructed specifically to support aircraft production. Steel alloys for aircraft frames required specialty furnaces that operated continuously, consuming coal and iron ore in quantities that exceeded Germany's total annual production. Rubber for aircraft tires, instruments, and seals demanded synthetic rubber plants that German chemists knew were theoretically possible but had never achieved at such scale. The aviation fuel production supporting American aircraft operations demonstrated industrial capacity that German planners found incomprehensible. High-octane aviation gasoline required refinery processes that American petroleum companies had perfected through continuous innovation. The 100-octane fuel that powered American fighters and bombers gave aircraft performance advantages over German planes running on lower-grade synthetic fuels. American refineries produced aviation fuel in quantities that exceeded total German fuel production by factors of 10. Every American bomber mission consumed more aviation fuel than the Luftwaffe received in weekly allocations. Fighter squadrons operated with fuel abundance that allowed unlimited training, extended combat operations, and wastage levels that would have grounded German units permanently. The transportation network supporting American aircraft production revealed organizational capabilities that German logistics officers studied with fascination and despair. Railroad systems moved aircraft components from factories across the continent to assembly plants with scheduling precision that ensured continuous production flow. Specialized aircraft carriers transported completed planes from manufacturing facilities to military bases without interrupting production schedules. The logistics of moving 96,000 aircraft annually from factories to operational units required coordination between transportation networks, military organizations, and civilian contractors on a scale that exceeded anything attempted in human history. German forces struggled to maintain supply lines across European distances, while Americans effortlessly coordinated production and delivery across an entire continent. Quality control in American aircraft manufacturing achieved standards that German engineers found remarkable for mass production. Despite producing aircraft at rates that seemed to prioritize quantity over quality, American factories maintained consistency that exceeded German artisanal production methods. Statistical quality control methods developed specifically for aircraft manufacturing ensured that aircraft rolling off production lines met specifications that would have required extensive individual testing under German production methods. American aircraft delivered to combat units operated reliably without the extensive modifications and adjustments that German aircraft required before becoming operational. This reliability translated into operational advantages that multiplied the effectiveness of American numerical superiority. The pilot training programs supporting American aircraft production revealed educational and organizational capabilities that German training commands envied. By 1944, American pilot training schools graduated more pilots monthly than Germany had trained in the entire war. Flying training programs operated from facilities specifically constructed for aviation education, using aircraft dedicated exclusively to instruction rather than diverted from combat operations. American pilot candidates received 250 hours of flight training before entering combat, compared to German pilots who were entering operational units with fewer than 50 hours of experience. The combination of superior aircraft numbers and better trained pilots created multiplicative advantages that German forces found impossible to counter. The research and development supporting American aircraft production demonstrated scientific and engineering capabilities that German technical organizations studied with professional admiration and strategic despair. American aircraft manufacturers operated research facilities that employed thousands of engineers developing improvements to existing designs and creating entirely new aircraft types. Wind tunnel testing, metallurgical research, and aerodynamic studies proceeded simultaneously across multiple facilities, generating innovations that were immediately incorporated into production aircraft. German aircraft development, constrained by resource limitations and competing priorities, could not match the scope and pace of American aviation research. New American aircraft designs progressed from concept to production in time frames that German engineers considered impossible for complex military systems. The economic foundation supporting American aircraft production revealed financial resources that German economists found difficult to comprehend. The United States allocated approximately 40% of total industrial capacity to military production, while maintaining civilian living standards that exceeded German peacetime levels. Aircraft production alone consumed resources equivalent to entire national economies, yet represented only a portion of American military manufacturing. The ability to sustain such production levels while simultaneously supporting allies with lend-lease deliveries demonstrated economic depth that German planners had never accurately assessed. American aircraft factories operated with financial backing that allowed continuous expansion, technological innovation, and production increases that German industry, operating under resource constraints, could never match. By late 1944, the cumulative impact of American aircraft production had fundamentally altered the strategic balance of World War II. German pilots found themselves outnumbered by ratios that made tactical excellence irrelevant. No amount of individual skill or superior aircraft design could compensate for facing 10 enemy aircraft for every German plane. The psychological impact on German aircrew was devastating. Experienced pilots who had dominated European skies in 1940 now faced swarms of American aircraft that replaced losses faster than German forces could inflict them. Every successful German mission resulted in aircraft losses that could not be replaced, while American losses were absorbed by production rates that exceeded attrition by comfortable margins. The psychological warfare embedded within American aircraft production numbers became clear to German commanders through captured intelligence documents that revealed the true scope of their industrial disadvantage. Wehrmacht intelligence reports from late 1944 painted a picture so bleak that some German generals initially refused to distribute them to subordinate commands. The documents revealed that American aircraft factories were not operating at maximum capacity. Despite producing nearly 100,000 aircraft annually, American manufacturing facilities maintained reserve production capability that could increase output by an additional 50% within 6 months, if required. German production, meanwhile, was straining every available resource to achieve output levels that represented barely 10% of American capacity. The spare parts production supporting American aircraft operations demonstrated logistical sophistication that German maintenance units observed with professional envy. Every American aircraft that rolled off production lines was accompanied by complete sets of replacement components manufactured to identical specifications. American maintenance depots stockpiled engine parts, instruments, control surfaces, and structural components in quantities that allowed complete aircraft rebuilds using standardized procedures. German aircraft maintenance, by contrast, required custom fabrication of replacement parts by skilled craftsmen who hand-fitted components to individual aircraft. The time required to repair battle damage that American crews fixed in hours often took German maintenance units days or weeks to complete. Weather testing facilities supporting American aircraft development revealed scientific approaches to aviation that German engineers found impressive, despite their strategic implications. American manufacturers operated climate chambers that could simulate Arctic conditions, tropical humidity, and desert heat to ensure aircraft performance across global operating environments. High-altitude chambers tested aircraft systems under conditions that replicated combat operations at 30,000 feet and above. These testing programs generated performance data that allowed American aircraft to operate reliably in conditions that grounded German planes designed for European weather patterns. The investment in testing infrastructure alone exceeded the total budget of German aircraft development programs. The aluminum recycling program supporting American aircraft production demonstrated resource management that German materials scientists studied with fascination. American factories established collection systems that recovered aluminum from damaged aircraft, manufacturing waste, and even civilian sources like cooking utensils donated by American families. Specialized smelting facilities could recycle aluminum scrap into new aircraft-grade alloys within weeks of collection. This recycling capability effectively extended American aluminum resources, while German aircraft production struggled with chronic shortages of high-grade aluminum alloys. The efficiency of American resource utilization multiplied the advantages already created by superior raw material access. Manufacturing flexibility within American aircraft production revealed industrial capabilities that German planners found strategically decisive. American factories could shift production between different aircraft types with modifications that required weeks rather than months. The North American aviation plant that produced P-51 Mustang fighters could be reconfigured to build different aircraft variants or entirely new designs using existing tooling and workforce skills. German aircraft factories, optimized for specific production runs, required extensive retooling and retraining to modify output. This flexibility allowed American production to respond rapidly to changing tactical requirements, while German manufacturing remained locked into production patterns established months earlier. The electrical systems manufacturing, supporting American aircraft, revealed technological integration that German electronics engineers found remarkably advanced. American aircraft incorporated radio equipment, navigation instruments, radar systems, and fire control computers that required precision electronics manufacturing on an industrial scale. Specialized facilities produced vacuum tubes, resistors, capacitors, and circuit boards in quantities that supplied not only American aircraft production, but also lend-lease deliveries to allied nations. German aircraft electronics, when available, represented artisanal production methods that could not achieve the standardization and reliability of American mass-produced systems. Fuel system manufacturing for American aircraft demonstrated engineering sophistication that German technical teams analyzed with professional respect and strategic concern. Self-sealing fuel tanks, pressurized fuel systems, and fuel injection equipment required manufacturing precision that combined with volume production in ways German industry had never achieved. American aircraft fuel systems operated reliably under combat conditions that would cause German fuel systems to fail catastrophically. The combination of superior fuel system design and manufacturing quality gave American aircraft survivability advantages that multiplied their numerical superiority. The paint and coating systems protecting American aircraft revealed chemical engineering capabilities that German materials scientists found impressive despite their implications. American aircraft factories applied protective coatings that resisted corrosion, reduced maintenance requirements, and provided camouflage effectiveness across multiple operational environments. The chemical plants supporting these coating systems produced specialized paints, primers, and sealants in quantities that exceeded German chemical production for all purposes. German aircraft often operated with minimal protective coatings due to material shortages, resulting in maintenance problems that reduced operational availability. Landing gear manufacturing for American aircraft demonstrated precision engineering scaled to mass production levels that German mechanical engineers found remarkable. Hydraulic systems, shock absorbers, wheels, and tires required manufacturing tolerances and material quality that German industry could achieve in limited quantities, but never at the scale demanded by American aircraft production rates. American landing gear systems operated reliably through thousands of landing cycles, while German landing gear often required replacement or extensive maintenance after relatively few operations. Armament systems manufacturing supporting American aircraft production revealed weapons integration that German ordnance engineers studied with professional admiration. Machine gun production, ammunition manufacturing, bomb production, and fire control systems required coordination between multiple industries operating at unprecedented scales. American aircraft entered combat with weapon systems that had been tested extensively and manufactured to specifications that ensured reliable operation under combat conditions. German aircraft armament, when available, often represented experimental installations or modifications that had received limited testing and integration work. Navigation equipment manufacturing for American aircraft demonstrated electronics production capabilities that German radio engineers found strategically significant. Radio compasses, altimeters, airspeed indicators, and communication equipment required precision manufacturing that American electronics industry had scaled to support not only domestic aircraft production, but also Allied requirements through Lend-Lease programs. American aircraft operated with navigation equipment that enabled precision flying under conditions that would ground German aircraft lacking equivalent systems. The photographic reconnaissance equipment supporting American aircraft operations revealed optical manufacturing capabilities that German intelligence services analyzed with particular interest. Cameras, film processing equipment, and interpretation systems required precision optics manufacturing combined with chemical processing capabilities that German industry could not match. American reconnaissance aircraft gathered intelligence with the equipment that produced photographic intelligence of higher quality and greater quantity than German reconnaissance capabilities could achieve. Training aircraft production supporting American pilot programs demonstrated educational resource allocation that German training commands found strategically decisive. America manufactured thousands of aircraft specifically designed for pilot training, using resources that German forces would have allocated to combat aircraft production. The investment in training infrastructure created pilot production capabilities that far exceeded German training capacity while simultaneously maintaining combat aircraft production at levels German industry could never approach. The medical equipment installed in American aircraft revealed life support manufacturing that German aviation medicine specialists found remarkably comprehensive. Oxygen systems, first aid equipment, survival gear, and emergency equipment required manufacturing capabilities that extended American industrial production into specialized medical equipment production. German aircraft often lacked basic life support equipment due to production priorities that allocated all available resources to combat systems rather than crew survival equipment. Communication equipment. Manufacturing for American aircraft demonstrated radio production capabilities that German signals intelligence services monitored with strategic concern. Every American aircraft carried radio equipment that enabled coordination with ground forces, other aircraft, and command centers with clarity and reliability that German communication systems could not match. The manufacturing scale required to equip tens of thousands of aircraft with sophisticated radio systems revealed electronics production capabilities that exceeded German electronics manufacturing for all military purposes. By early 1945, German aviation commanders faced the mathematical reality that American aircraft production had achieved levels that made continued resistance strategically meaningless. Intelligence estimates indicated that American factories were producing aircraft faster than German forces could destroy them, even if every German mission achieved perfect success rates. The cumulative effect of sustained production at unprecedented levels had created American air superiority so complete that German aircraft operations had become tactically irrelevant to the war's ultimate outcome. The realization struck German commanders with devastating clarity as they studied captured American maintenance manuals recovered from downed aircraft. These technical documents revealed production planning that extended years into the future, with spare parts, inventories calculated to support aircraft operations through 1947 and beyond. American logistics officers were planning for a war that might continue for years while maintaining aircraft readiness rates that German forces could barely achieve during peacetime. The manuals documented maintenance schedules that assumed unlimited access to replacement components, specialized tools, and technical expertise that German maintenance crews could only dream of possessing. German aircraft factories struggled to comprehend American production methods described in captured industrial intelligence reports. Photographs taken by German agents showed assembly lines where aircraft moved through production stations with mechanical precision that resembled clockwork more than traditional manufacturing. Workers performed identical tasks repeatedly with training that specialized them in single operations rather than the comprehensive craftsmanship that German aircraft production required. This specialization created efficiency levels that German master craftsmen, despite their superior individual skills, could never match when measured against American mass production capabilities. The rubber production supporting American aircraft manufacturing revealed synthetic chemistry achievements that German chemicaled natural rubber quality, while engineers found professionally humbling. American synthetic rubber plants produced materials that exceeded operating at scales that dwarfed German synthetic production attempts. Aircraft tires, seals, gaskets, and flexible components required rubber products manufactured to specifications that German chemistry could achieve in laboratory quantities, but never at production levels. American aircraft operated with rubber components that maintained performance characteristics under temperature extremes and stress levels that would cause German rubber products to fail catastrophically. Glass manufacturing for American aircraft demonstrated precision optics production that German optical engineers analyzed with grudging respect. Bulletproof windscreens, navigation windows, bomb sights, and instrument panels required optical glass manufacturing that combined clarity, strength, and precision in ways German optical industry had never scaled beyond specialized applications. American aircraft featured glass components that provided visibility and protection levels that enhanced crew performance, while German aircraft often operated with compromised visibility due to optical glass shortages and quality limitations. Instrument manufacturing supporting American aircraft production revealed precision mechanical engineering scaled to levels that German instrument makers found remarkable. Altimeters, airspeed indicators, engine gauges, and navigation instruments required manufacturing tolerances and reliability standards that American instrument companies achieved through mass production techniques. German aircraft instruments, when available, represented individual craftsmanship that achieved superior precision in limited quantities, but could never match American instrument production volumes or standardization levels. The testing procedures employed in American aircraft manufacturing demonstrated quality assurance methods that German production engineers studied with professional fascination. Every aircraft underwent comprehensive testing that included engine runs, systems checks, flight testing, and performance verification before delivery to military units. American test pilots flew every aircraft through standardized evaluation procedures that ensured consistent performance across thousands of identical machines. German aircraft testing constrained by fuel shortages and pilot availability, often consisted of minimal ground testing before delivery to operational units that discovered performance problems during combat operations. Climate control systems in American aircraft factories revealed environmental engineering that German industrial planners found strategically significant. Manufacturing facilities maintained temperature and humidity control that ensured consistent production quality regardless of seasonal weather variations. Precision manufacturing required environmental stability that American factories achieved through heating, cooling, and air filtration systems that consumed energy in quantities that exceeded total German industrial power allocation. German aircraft factories operated without environmental controls, resulting in production quality variations that affected aircraft performance and reliability. Tool and die manufacturing. Supporting American aircraft production demonstrated precision tooling capabilities that German machine tool engineers found impressive, despite their strategic implications. Specialized manufacturing equipment, precision measuring instruments, and production tooling required machine tool production that operated at scales exceeding German machine tool manufacturing for all purposes. American aircraft factories employed tooling that maintained manufacturing precision through millions of production cycles, while German tooling often required replacement or extensive maintenance after relatively limited use. The transportation infrastructure supporting American aircraft delivery revealed logistics coordination that German transportation officers studied with strategic despair. Specialized aircraft transport systems moved completed aircraft from manufacturing facilities to military bases using methods that minimized handling damage and delivery delays. Railroad systems designed specifically for aircraft transport, truck convoys equipped for oversized cargo, and ferry flights coordinated by dedicated air transport commands created delivery capabilities that exceeded German transportation capacity for all military supplies combined. Packaging and preservation systems protecting American aircraft components demonstrated chemical engineering applied to logistics in ways German supply officers found remarkably comprehensive. Specialized packaging materials, preservative coatings, and storage procedures ensured that aircraft components maintained quality during extended storage and transportation. American supply depots stockpiled aircraft parts in quantities that remained serviceable for years, while German aircraft components often deteriorated during brief storage periods due to inadequate preservation methods and materials shortages. The financial accounting systems tracking American aircraft production revealed cost control methods that German industrial accountants found strategically enlightening. Despite operating at unprecedented scales, American aircraft manufacturers maintained detailed cost tracking that identified efficiency improvements and resource optimization opportunities. Production costs per aircraft declined steadily, despite continuous design improvements and quality enhancements. German aircraft production, operating under resource constraints and competing priorities, experienced continuously increasing costs per aircraft as materials became scarcer and manufacturing became more difficult. Personnel management in American aircraft factories demonstrated human resource capabilities that German industrial managers found remarkable for wartime production. Training programs, safety procedures, productivity incentives, and worker welfare programs created manufacturing environments that sustained high productivity levels across multiple shifts operating continuously. American aircraft workers maintained production quality and efficiency that German managers knew required worker satisfaction and organizational effectiveness that German industry could not achieve under wartime conditions. Security procedures protecting American aircraft manufacturing revealed counterintelligence capabilities that German intelligence services found professionally impressive. Manufacturing facilities operated under security protocols that prevented industrial espionage while maintaining production efficiency. American factories protected production secrets, design information, and manufacturing techniques through security systems that German intelligence found difficult to penetrate, despite extensive efforts. The combination of physical security, personnel screening, and information protection created manufacturing security that exceeded German capabilities for protecting their own production facilities. Research documentation supporting American aircraft development demonstrated scientific record-keeping that German research organizations found methodically comprehensive. Engineering drawings, test results, design modifications, and performance data were recorded with precision that enabled continuous improvement and rapid problem-solving. American aircraft manufacturers maintained technical libraries that documented every aspect of design and production with accuracy, that allowed manufacturing improvements to be implemented across multiple production facilities simultaneously. The metallurgical testing supporting American aircraft manufacturing revealed materials, science capabilities that German metallurgists found strategically decisive. Specialized testing equipment, quality control procedures, and materials certification systems ensured that aircraft structural materials met specifications that guaranteed performance under combat conditions. American aircraft operated with materials that maintained strength and reliability characteristics that German metallurgy could achieve in laboratory conditions, but never at production scales required for mass aircraft manufacturing. Electrical power systems in American aircraft factories demonstrated industrial electrical engineering that German power engineers found remarkable for manufacturing applications. Electrical distribution, motor control, lighting systems, and power quality management created manufacturing environments that supported precision production equipment operating continuously. American aircraft factories consumed electrical power in quantities that exceeded total German industrial power consumption, while maintaining power quality that enabled precision manufacturing impossible under German electrical supply conditions. The waste management systems in American aircraft factories revealed resource recovery capabilities that German materials engineers found economically impressive. Manufacturing waste, metal scraps, defective components, and byproducts were recovered and recycled through systems that minimized material losses while maintaining production efficiency. American aircraft manufacturers achieved material utilization rates that German industry could not match due to waste recovery systems that operated at industrial scales German recycling capabilities could never approach. Ventilation systems in American aircraft manufacturing facilities demonstrated air quality engineering that German industrial hygienists found remarkable for worker health and production quality. air filtration, fume extraction, dust control, and atmospheric de-worker health, while preventing monitoring created working environments that protected contamination of precision manufacturing processes. American aircraft workers operated in environmental conditions that exceeded German peacetime industrial standards, while maintaining production rates that German industry could not achieve under any conditions. The procurement systems coordinating American aircraft manufacturing revealed supply chain management that German logistics officers found strategically overwhelming. Raw materials, components, sub-assemblies, and finished products flowed through supply networks that coordinated thousands of suppliers across continental distances with timing precision that ensured continuous production flow. American aircraft manufacturers operated supply chains that delivered materials with reliability and efficiency that German supply systems could not achieve for military operations within European distances. By spring 1945, German aviation industry leaders privately acknowledged that American aircraft production had achieved levels that represented not just quantitative superiority, but qualitative transformation of manufacturing itself. The combination of scale, efficiency, quality, and technological sophistication had created aircraft production capabilities that redefined what industrial societies could achieve when fully mobilized. German aircraft production, despite employing skilled workers and advanced engineering, represented traditional manufacturing methods that could not compete against American Industrial Revolution applied to aviation manufacturing. The final intelligence reports reaching German aviation commands painted a picture so complete in its demonstration of American industrial superiority that some German officers refused to believe the documentation. American aircraft production had achieved sustainability that could continue indefinitely, while German production was consuming resources faster than they could be replaced. The mathematical reality was inescapable. American factories were producing aircraft at rates that made continued German resistance equivalent to fighting against industrial infinity. The sky belonged to America, not through temporary advantage, but through manufacturing capabilities that had fundamentally altered the nature of aerial warfare forever. The scope of American aircraft production extended far beyond simple manufacturing into realms that German industrial planners had never considered possible during wartime operations. By 1945, American factories were not merely building aircraft faster than any nation in history, they were creating entirely new categories of aviation technology while maintaining production rates that defied every assumption German engineers held about manufacturing limitations. The Bell Aircraft Corporation was simultaneously producing P-39 Cobra fighters, developing the revolutionary P-59 jet fighter, and researching rocket-powered interceptors that promised performance levels German designers could only theorize about. This parallel development of current production and future technology revealed in industrial depth that German aviation industry had never imagined achievable. The magnesium production supporting American aircraft manufacturing demonstrated materials, science, scaled to levels that left German metallurgists struggling to comprehend the logistical implications. Magnesium alloys for aircraft engines, instrument housings, and structural components required mining operations, smelting facilities, and fabrication capabilities that consumed electrical power equivalent to entire European industrial regions. The Dow Chemical Company's magnesium plants alone produced more strategic metals monthly than Germany's total annual output from all sources combined. American aircraft incorporated magnesium components as standard equipment, while German aircraft designers allocated magnesium usage with the precision reserved for precious metals. Hydraulic systems manufacturing for American aircraft revealed fluid power engineering that German hydraulic specialists found remarkably sophisticated for mass production applications. Landing gear actuation, flight control systems, bomb bay doors, and turret mechanisms required hydraulic components manufactured to tolerances that ensured reliable operation through thousands of operational cycles. American hydraulic systems operated at pressures and flow rates that German hydraulic technology could achieve in experimental installations, but never at the production scales required for equipping tens of thousands of aircraft simultaneously. The carburetor production supporting American aircraft engines demonstrated precision fuel metering technology that German engine engineers analyzed with professional admiration and strategic despair. Each American aircraft engine required fuel injection systems that maintained optimal fuel-air mixtures across altitude ranges from sea level to 40,000 feet, while operating under combat stresses that would destroy German carburetor systems within hours. American carburetor manufacturers produced these precision instruments at rates that exceeded German production of all engine components combined, using manufacturing techniques that achieved reliability standards. German engine builders could only approximate through individual hand-fitting procedures. Propeller manufacturing for American aircraft revealed aerodynamic engineering scaled to production levels that German propeller specialists found strategically decisive. Variable pitch propellers, constant speed governors, and blade pitch control systems required manufacturing precision that combined metallurgy, hydraulics, and aerodynamics in ways German propeller industry had mastered for limited production runs, but never at American manufacturing scales. Hamilton Standard propellers equipped American aircraft with performance capabilities that German fixed-pitch propellers could not match, while being produced in quantities that exceeded total German propeller manufacturing by factors approaching 10 to 1. The bearing production supporting American aircraft engines demonstrated precision manufacturing that German bearing engineers found remarkable for wartime industrial conditions. Engine bearings, control surface bearings, landing gear bearings, and instrument bearings required manufacturing tolerances measured in 10,000ths of an inch, while maintaining surface finishes that ensured reliable operation under extreme temperature and stress conditions. American bearing manufacturers achieved these precision standards through mass production techniques that German bearing industry could only approximate through individual craftsmanship requiring weeks rather than hours per component. Fabric production for American aircraft demonstrated textile manufacturing adapted to aviation requirements in ways German textile engineers found impressive, despite their strategic implications. Fabric covering for control surfaces, interior panels, parachutes, and life support equipment required specialized weaving, coating, and treatment processes that created materials meeting military specifications while being produced in quantities that exceeded German textile production for all military purposes. American textile manufacturers had developed aviation fabrics that maintained strength and flexibility under conditions that would cause German aviation textiles to fail catastrophically. The welding rod production supporting American aircraft manufacturing revealed metallurgical chemistry that German welding specialists found strategically significant. Aluminum welding, steel welding, and specialized alloy joining required welding consumables manufactured to specifications that ensured consistent weld quality across millions of individual joints. American welding rod manufacturers produced specialized consumables that enabled aircraft structural welding with reliability standards that German welding technology could achieve only through extensive individual testing and qualification procedures that made mass production impossible. Rivet production for American aircraft assembly demonstrated fastener manufacturing scaled to levels that German fastener engineers found remarkable for precision applications. Aircraft assembly required rivets manufactured to tolerances that ensured structural integrity while being installed at rates that supported assembly line production schedules. American rivet manufacturers produced billions of specialized fasteners annually while maintaining dimensional accuracy and material properties that German fastener production could achieve in limited quantities, requiring extensive individual inspection and testing procedures. The sealant production supporting American aircraft manufacturing revealed chemical engineering that German materials scientists found professionally impressive. Fuel tank sealants, cabin pressurization seals, hydraulic system seals, and environmental protection compounds required chemical formulations that maintained effectiveness under temperature extremes, pressure variations, and chemical exposures that would destroy German sealing compounds within operational periods measured in hours rather than months. American chemical companies had developed aviation sealants through research programs that exceeded German chemical research budgets for all military applications combined. Electrical cable production for American aircraft demonstrated precision electrical manufacturing that German electrical engineers found strategically enlightening. Aircraft electrical systems required thousands of feet of specialized wiring per aircraft, manufactured to specifications that ensured reliable electrical transmission under vibration, temperature extremes, and electromagnetic interference conditions that would cause German electrical systems to fail unpredictably. American electrical manufacturers produced aviation wiring with insulation materials and conductor specifications that German electrical industry could not replicate due to materials limitations and manufacturing capability constraints. The battery production supporting American aircraft electrical systems revealed electrochemical engineering scaled to levels that German battery specialists found remarkable for military applications. Aircraft batteries required energy storage capabilities that operated reliably under acceleration forces, temperature variations, and vibration conditions that would destroy German battery systems within operational periods. American battery manufacturers produced aviation batteries with performance characteristics and manufacturing consistency that German electrochemical industry could achieve in laboratory conditions, but never at production scales required for equipping aircraft fleets. Compass production for American aircraft navigation systems demonstrated precision instrument manufacturing that German instrument makers found impressive despite competitive implications. Magnetic compasses, gyroscopic compasses, and radio compasses required manufacturing precision that maintained navigational accuracy under aircraft operational conditions while being produced in quantities that equipped every American aircraft with redundant navigation capabilities. German compass production, constrained by materials shortages and precision manufacturing limitations, could not achieve American compass production rates or reliability standards. The parachute production supporting American aircrew safety demonstrated textile engineering that German parachute manufacturers found strategically significant. Pilot parachutes, cargo parachutes, and emergency equipment required specialized fabric weaving, harness manufacturing, and deployment system production that ensured reliable operation under emergency conditions. American parachute manufacturers produced life support equipment with reliability standards that German parachute industry could not match due to materials limitations and testing capability constraints that prevented comprehensive quality assurance programs. Tire production for American aircraft landing systems revealed rubber engineering scaled to levels that German tire manufacturers found remarkable for aviation applications. Aircraft tires required rubber compounds that maintained performance characteristics under landing loads, taxi operations, and environmental conditions that would destroy German aircraft tires within operational periods measured in landings rather than months. American tire manufacturers produced aviation tires with specifications that German rubber industry could not achieve due to synthetic rubber limitations and manufacturing process constraints. The valve production supporting American aircraft hydraulic and pneumatic systems demonstrated precision mechanical engineering that German valve specialists found professionally impressive. Hydraulic valves, pneumatic valves, fuel valves, and environmental control valves required manufacturing precision that ensured reliable operation under pressure differentials and flow rates that would cause German valve systems to fail unpredictably. American valve manufacturers achieved these performance standards through mass production techniques that German valve industry could only approximate through individual craftsmanship, requiring extensive testing and qualification procedures. Filter production for American aircraft systems revealed filtration engineering that German filter manufacturers found strategically decisive. Air filters, fuel filters, oil filters, and hydraulic filters required filtration media and housing manufacturing that maintained system cleanliness under operational conditions while being produced in quantities that equipped every American aircraft with comprehensive filtration protection. German filter production could not achieve American filtration performance standards or manufacturing scales due to materials limitations and production capability constraints. The gasket production supporting American aircraft assembly demonstrated sealing technology scaled to levels that German gasket manufacturers found remarkable for precision applications. Engine gaskets, fuel system gaskets, hydraulic gaskets, and environmental seals required materials and manufacturing precision that maintained sealing effectiveness under pressure, temperature, and chemical conditions that would cause German gasket systems to fail within operational periods. American gasket manufacturers produced specialized sealing components with reliability that German sealing industry could achieve only through individual fitting and testing procedures. Spring production for American aircraft control systems revealed precision mechanical engineering that German spring specialists found strategically significant. Control springs, landing gear springs, engine valve springs, and instrument springs required manufacturing precision that maintained force characteristics and operational reliability under cyclic loading conditions that would cause German spring systems to fail unpredictably. American spring manufacturers achieved these performance standards through metallurgical control and manufacturing techniques that German spring industry could not replicate at production scales. The bolt production supporting American aircraft assembly demonstrated fastener engineering scaled to levels that German fastener specialists found impressive despite competitive implications. Structural bolts, engine bolts, control system bolts, and specialized fasteners required manufacturing precision that ensured structural integrity while being produced in quantities that supported assembly line production schedules. American bolt manufacturers produced specialized fasteners with strength characteristics and dimensional accuracy that German fastener production could achieve only through extensive individual testing and qualification procedures. Hose production for American aircraft fluid systems revealed flexible conduit manufacturing that German hose specialists found remarkable for aviation applications. Hydraulic hoses, fuel hoses, oil hoses, and pneumatic hoses required materials and manufacturing techniques that maintained fluid containment under pressure, temperature, and vibration conditions that would cause German hose systems to fail within operational periods. American hose manufacturers produced aviation fluid conduits with specifications that German flexible conduit industry could not achieve due to materials limitations and manufacturing process constraints. The switch production supporting American aircraft electrical systems demonstrated precision electrical component manufacturing that German electrical specialists found strategically enlightening. Control switches, circuit protection switches, navigation switches, and communication switches required electrical contact materials and housing precision that ensured reliable electrical operation under operational conditions while being produced in quantities that equipped every American aircraft with comprehensive electrical control capabilities. German electrical switch production could not achieve American electrical reliability standards or manufacturing scales. Lens production for American aircraft optical systems revealed precision optics manufacturing that German optical engineers found professionally impressive. Navigation lights, instrument illumination, bomb sight optics, and camera lenses required optical precision and coating technology that maintained optical performance under environmental conditions while being produced in quantities that equipped aircraft with comprehensive optical capabilities. German optical production could achieve superior individual lens quality, but could not match American optical manufacturing scales or production consistency. The wire rope production supporting American aircraft control systems demonstrated precision cable manufacturing that German cable specialists found strategically significant. Control cables, antenna cables, and structural cables required materials and manufacturing techniques that maintained tensile strength and flexibility under operational stresses, while being produced in lengths that equipped aircraft fleets with reliable cable systems. American cable manufacturers produced aviation wire rope with specifications that German cable industry could achieve in limited quantities, requiring extensive individual testing procedures. Fuel pump production for American aircraft fuel systems revealed precision pump manufacturing scaled to levels that German pump specialists found remarkable for aviation applications. Engine fuel pumps, transfer pumps, and auxiliary pumps required manufacturing precision that maintained fuel flow rates and pressure characteristics under operational conditions while being produced in quantities that equipped every American aircraft with redundant fuel system capabilities. German pump production could not achieve American fuel pump reliability standards or manufacturing scales due to precision manufacturing limitations. The actuator production supporting American aircraft control systems demonstrated precision mechanical engineering that German actuator specialists found strategically decisive. Flight control actuators, landing gear actuators, and auxiliary system actuators required manufacturing precision that maintained force output and positional accuracy under operational loads while being produced in quantities that equipped aircraft with comprehensive automated control capabilities. American actuator manufacturers achieved performance standards that German actuator industry could only approximate through individual calibration and testing procedures. Sensor production for American aircraft monitoring systems revealed precision instrumentation manufacturing that German sensor specialists found impressive despite competitive implications. Engine sensors, flight sensors, navigation sensors, and environmental sensors required manufacturing precision that maintained measurement accuracy under operational conditions while being produced in quantities that equipped every American aircraft with comprehensive system monitoring capabilities. German sensor production could not achieve American sensor reliability standards or manufacturing scales due to precision manufacturing and materials constraints. The coupling production supporting American aircraft systems demonstrated precision mechanical connection, manufacturing that German coupling specialists found remarkable for aviation applications. Hydraulic couplings, electrical couplings, fuel couplings, and mechanical couplings required manufacturing precision that maintained connection reliability under operational stresses while being produced in quantities that supported assembly line production schedules and field maintenance requirements. American coupling manufacturers produced specialized connection components with reliability that German coupling industry could achieve only through individual fitting procedures. By summer 1945, German aviation technical intelligence had compiled reports documenting American aircraft production capabilities that revealed industrial achievements transcending every assumption about manufacturing limitations during wartime operations. The reports described not merely superior production quantities, but systematic technological advancement across every aspect of aviation manufacturing that had created American aircraft production capabilities operating at levels German industry had never contemplated as achievable under any circumstances. The mathematical reality confronting German aviation commands was inescapable. American factories had achieved aircraft production sustainability that could continue expanding while German production was consuming irreplaceable resources, as at rates that guaranteed industrial collapse within months regardless of military outcomes. The psychological impact of these revelations spread through German aviation commands, with devastating effect on strategic planning and tactical decision-making. Officers who had spent careers developing aviation technology and production methods found themselves confronting evidence that American industry had achieved manufacturing capabilities that rendered German aviation efforts strategically irrelevant. The reports documented American aircraft production operating with resource abundance, technological sophistication, and organizational efficiency that exceeded German peacetime industrial capabilities, while simultaneously supporting global military operations on scales that German logistics had never contemplated as possible. German aviation industry leaders studying captured American production manuals discovered manufacturing methods that revealed systematic approaches to industrial organization that transcended traditional European concepts of manufacturing limitations. The manuals described production planning extending years into the future with resource allocation, workforce training, and technological development programs that assumed continued expansion of manufacturing capabilities already operating beyond German comprehension of industrial possibility. American aircraft production represented not temporary wartime achievement, but permanent transformation of manufacturing capability that would continue developing long after military requirements had ended. The final German aviation intelligence assessments acknowledged that American aircraft production had demonstrated industrial capabilities that fundamentally redefined the relationship between manufacturing capacity and military power. The reports concluded that American factories had achieved aircraft production levels that made traditional concepts of military-industrial balance obsolete, creating aviation manufacturing capabilities that could sustain any conceivable level of military operations while continuing technological development that would maintain American aviation superiority indefinitely. The sky belonged to America through manufacturing achievements that had transformed industrial warfare from competition into demonstration of overwhelming productive superiority that no intentional military response could challenge or overcome. The industrial intelligence reports reaching Berlin in the final months of the war contained details so staggering that German aviation engineers initially questioned their own data collection methods. American factories were not simply producing aircraft at unprecedented rates, they were simultaneously developing entirely new categories of aviation technology that promised to render current aircraft obsolete within years. The Glenelg Martin Company was producing B-26 Marauder bombers, while simultaneously developing jet-powered medium bombers that would make propeller-driven aircraft tactically irrelevant. This parallel development of current production and revolutionary future technology demonstrated industrial planning capabilities that German aviation industry had never conceived as rationally feasible during wartime conditions. The specialized tooling production supporting American aircraft manufacturing revealed precision engineering scaled to levels that German machine tool specialists found impossible to reconcile with their understanding of wartime production constraints. Every American aircraft required thousands of specialized tools, jigs, fixtures, and gauges manufactured to tolerances that ensured assembly line precision across multiple production facilities. The Cincinnati Milling Machine Company alone produced more precision tooling monthly than German machine tool industry managed annually from all sources combined. American aircraft manufacturers operated with tooling inventories that represented investment levels exceeding Germany's total machine tool capital for treatment facilities, all industrial ISP. Purposes. Heat-supporting American aircraft metallurgy demonstrated materials processing capabilities that German metallurgical engineers found strategically overwhelming. Aircraft structural components, engine parts, and precision mechanisms required heat treatment processes that controlled material properties with consistency that ensured reliable performance across thousands of identical components. American heat treatment facilities processed aircraft materials using furnace technology, atmosphere control systems, and temperature monitoring equipment that consumed energy quantities exceeding total German industrial power allocation while maintaining metallurgical precision that German materials science could achieve only through laboratory-scale processing procedures. The inspection equipment used in American aircraft quality control revealed measurement technology that German precision instrument specialists found remarkable for production applications. Coordinate measuring machines, precision gauges, optical comparators, and dimensional verification equipment enabled quality control procedures that verified manufacturing accuracy across millions of individual measurements daily. American aircraft manufacturers maintained quality standards through inspection capabilities that German precision instrument industry could not supply at any production scale. Using measurement technology that required manufacturing precision exceeding German capability for producing the measuring instruments themselves. Cutting fluid production for American aircraft machining operations demonstrated chemical engineering that German metalworking specialists found strategically significant. Machining aircraft components required specialized cutting fluids that maintained tool life, surface finish quality, and dimensional accuracy through millions of machining operations. American chemical companies produced metalworking fluids with performance characteristics that enabled machining productivity levels that German metalworking industry could not achieve due to cutting fluid limitations that reduced tool life and machining accuracy to levels that made precision production impossible at American manufacturing scales. The foundry operations supporting American aircraft casting requirements revealed metallurgical production capabilities that German foundry specialists found impressive despite competitive implications. Aircraft engines, landing gear components, and structural fittings required precision castings that maintained dimensional accuracy and material properties through foundry processes that produced thousands of identical components. American foundry operations achieved casting quality standards that German foundry industry could approximate through individual sand casting procedures, but never at production scales that supported assembly line manufacturing schedules. Forging operations for American aircraft structural components demonstrated metalworking capabilities that German forging specialists found strategically decisive. Aircraft structural members, landing gear components, and engine parts required forging processes that controlled grain structure and material properties while maintaining dimensional accuracy through high-volume production procedures. American forging facilities produced aircraft forgings with metallurgical consistency that German forging industry could achieve through individual hammer forging procedures, but never at production rates that supported continuous assembly line operations. The plating operations supporting American aircraft corrosion protection revealed electrochemical processing scaled to levels that German plating specialists found remarkable for aviation applications. Corrosion protection, wear resistance, and electrical conductivity requirements demanded plating processes that maintained coating thickness, adhesion, and quality characteristics across millions of individual components. American plating facilities processed aircraft components through electrochemical procedures that consumed electrical power and chemical materials in quantities that exceeded German plating industry capacity for all military applications, while maintaining coating quality that German plating processes could achieve only through individual processing and inspection procedures. Grinding operations for American aircraft precision components demonstrated abrasive machining capabilities that German grinding specialists found professionally impressive. Engine components, bearing surfaces, and precision mechanisms required grinding processes that maintained surface finish and dimensional accuracy through high-volume production procedures. American grinding operations achieved surface quality standards that German grinding industry could approximate through individual precision grinding procedures, but never at production scales that supported assembly line manufacturing schedules requiring thousands of precision ground components daily. The milling operations supporting American aircraft machining requirements revealed machine tool utilization that German machining specialists found strategically significant. Aircraft structural components, engine parts, and precision mechanisms required milling processes that maintained dimensional accuracy and surface quality through continuous production procedures. American milling operations achieved machining productivity that German machining industry could not match due to machine tool limitations, cutting tool constraints, and precision maintenance requirements that prevented sustained, high-volume precision machining operations. Drilling operations for American aircraft assembly procedures demonstrated precision hole-making capabilities that German drilling specialists found remarkable for production applications. Aircraft assembly required millions of precision holes that maintained positional accuracy, surface finish, and dimensional tolerances that ensured reliable fastener installation and structural integrity. American drilling operations achieved hole-making precision that German drilling industry could approximate through individual drilling procedures, but never at production rates that supported assembly line schedules requiring thousands of precision holes daily per aircraft. The turning operations supporting American aircraft component manufacturing revealed precision lathe work scaled to levels that German turning specialists found strategically overwhelming. Engine components, landing gear parts, and precision mechanisms required turning processes that maintained dimensional accuracy and surface quality through high-volume production procedures. American turning operations achieved machining precision that German turning industry could approximate through individual precision lathe work, but never at production scales that supported continuous component manufacturing for aircraft assembly lines. Assembly line engineering for American aircraft production demonstrated manufacturing organization that German industrial engineers found impossible to reconcile with their understanding of complex product assembly procedures. Aircraft assembly required coordination of thousands of components, sub-assemblies, and systems through production sequences that maintained quality standards, while achieving completion rates that supported delivery schedules. American aircraft manufacturers had developed assembly procedures that achieved production consistency that German aircraft industry could not match through traditional aircraft construction methods that required individual craftsmanship and custom fitting procedures. The materials handling systems supporting American aircraft manufacturing revealed logistics automation that German materials handling specialists found strategically decisive. Moving components, sub-assemblies, and completed aircraft through production facilities required materials handling equipment that operated with precision timing that supported assembly line schedules without interrupting production flow. American aircraft manufacturers employed materials handling systems that moved production materials with efficiency levels that German materials handling industry could not achieve due to automation technology limitations and power system constraints. Inventory control systems for American aircraft production demonstrated supply chain management that German logistics specialists found remarkable for complex manufacturing operations. Aircraft production required coordination of hundreds of thousands of individual components with delivery timing that ensured continuous assembly line operations without inventory shortages or excessive storage requirements. American aircraft manufacturers maintained inventory control through management systems that achieved supply chain coordination that German logistics industry could not replicate due to information processing limitations and communication system constraints. The production scheduling systems coordinating American aircraft manufacturing revealed industrial planning capabilities that German production planners found professionally impressive. Aircraft assembly required coordination of multiple production lines, supplier deliveries, and completion schedules that maintained production flow while adapting to changing requirements and resource availability. American aircraft manufacturers achieved production scheduling efficiency that German production planning could not match due to information processing limitations and coordination system constraints that prevented comprehensive production control. Maintenance systems for American aircraft production equipment demonstrated industrial service capabilities that German maintenance specialists found strategically significant. Aircraft manufacturing equipment required maintenance procedures that ensured continuous operation while maintaining precision standards that supported quality production. American aircraft manufacturers maintained production equipment through service systems that achieved operational reliability that German maintenance industry could not replicate due to spare parts limitations, service capability constraints, and maintenance system organization limitations. The power distribution systems supporting American aircraft manufacturing facilities revealed electrical engineering scaled to levels that German electrical engineers found remarkable for industrial applications. Aircraft production required electrical power distribution that maintained power quality and reliability standards that supported precision manufacturing equipment operating continuously. American aircraft manufacturers operated electrical systems that consumed power quantities exceeding German electrical generation capacity, while maintaining power quality that enabled precision manufacturing impossible under German electrical supply conditions. Compressed air systems for American aircraft manufacturing operations demonstrated pneumatic engineering that German pneumatic specialists found strategically decisive. Aircraft assembly required compressed air systems that maintained pressure, flow rate, and air quality standards that supported pneumatic tools and equipment operating continuously throughout production facilities. American aircraft manufacturers operated compressed air systems with capacity and reliability that German pneumatic industry could not achieve due to compressor technology limitations and air treatment capability constraints. The steam systems supporting American aircraft manufacturing facilities revealed thermal engineering that German steam specialists found impressive despite competitive implications. Aircraft production required steam systems that provided heating, process steam, and power generation that supported manufacturing operations while maintaining temperature and pressure standards that ensured production quality. American aircraft manufacturers operated steam systems with capacity and efficiency that German steam industry could not match due to boiler technology limitations and fuel availability constraints. Water systems for American aircraft manufacturing operations demonstrated fluid handling engineering that German water system specialists found remarkable for industrial applications. Aircraft production required water systems that provided cooling, cleaning, and process water that supported manufacturing operations while maintaining flow rates and quality standards that ensured production continuity. American aircraft manufacturers operated water systems with capacity and reliability that German water system industry could not achieve due to pumping technology limitations and treatment capability constraints. Waste heat recovery systems in American aircraft manufacturing facilities revealed thermal efficiency engineering that German thermal specialists found strategically significant. Aircraft production generated waste heat from manufacturing processes that could be recovered and utilized for facility heating, process applications, and power generation that improved overall energy efficiency. American aircraft manufacturers employed waste heat recovery systems that achieved thermal efficiency levels that German thermal engineering could not replicate due to heat exchanger technology limitations and system integration constraints. The fire protection systems safeguarding American aircraft manufacturing facilities demonstrated safety engineering scaled to levels that German fire protection specialists found remarkable for industrial applications. Aircraft production facilities required fire protection systems that provided detection, suppression, and evacuation capabilities that protected personnel, equipment, and production materials while maintaining manufacturing operations. American aircraft manufacturers operated fire protection systems with capability and reliability that German fire protection industry could not achieve due to detection technology limitations and suppression system capability constraints. Ventilation systems for American aircraft manufacturing operations revealed air handling engineering that German ventilation specialists found strategically decisive. Aircraft production required ventilation systems that maintained air quality, temperature control, and contaminant removal that supported manufacturing operations while protecting worker health and production quality. American aircraft manufacturers operated ventilation systems with capacity and efficiency that German ventilation industry could not match due to fan technology limitations and air treatment capability constraints. The lighting systems illuminating American aircraft manufacturing facilities demonstrated electrical engineering that German lighting specialists found impressive despite competitive implications. Aircraft production required lighting systems that provided illumination levels, uniformity, and quality that supported precision manufacturing operations while maintaining energy efficiency and reliability. American aircraft manufacturers operated lighting systems with performance characteristics that German lighting industry could not achieve due to lamp technology limitations and electrical control system constraints. Material testing laboratories supporting American aircraft development revealed scientific capabilities that German materials scientists found strategically overwhelming. Aircraft development required materials testing that verified strength, durability, and performance characteristics under operational conditions that simulated years of service in accelerated testing procedures. American aircraft manufacturers operated materials testing facilities that conducted testing programs exceeding German materials' science capability for all research purposes, while maintaining testing schedules that supported continuous product development and improvement programs. The environmental testing chambers used in American aircraft development demonstrated simulation technology that German testing specialists found remarkable for engineering applications. Aircraft systems required environmental testing that simulated altitude, temperature, humidity, and vibration conditions that verified performance under operational environments before production implementation. American aircraft manufacturers operated environmental testing facilities with simulation capabilities that German testing industry could not achieve due to environmental chamber technology limitations and control system capability constraints. Prototype manufacturing facilities supporting American aircraft development revealed rapid fabrication capabilities that German prototype specialists found strategically significant. Aircraft development required prototype construction that enabled design verification, performance testing, and modification evaluation through rapid fabrication procedures that supported accelerated development schedules. American aircraft manufacturers maintained prototype facilities with fabrication capabilities that German prototype industry could not match due to rapid manufacturing technology limitations and materials processing capability constraints. The technical documentation systems supporting American aircraft production demonstrated information management capabilities that German documentation specialists found professionally impressive. Aircraft manufacturing required technical documentation that maintained design information, manufacturing procedures, and quality standards through information systems that ensured accuracy and accessibility across multiple production facilities. American aircraft manufacturers operated documentation systems that managed technical information with accuracy and efficiency that German documentation industry could not replicate due to information processing limitations and document control system constraints. Training facilities for American aircraft manufacturing personnel revealed educational capabilities that German training specialists found strategically decisive. Aircraft production required workforce training that developed manufacturing skills, quality procedures, and safety practices through educational programs that maintained worker competency across expanding production operations. American aircraft manufacturers operated training facilities with educational capabilities that German training industry could not achieve due to instructional technology limitations and training program development capability constraints. Research libraries supporting American aircraft development demonstrated information resources that German research specialists found remarkable for engineering applications. Aircraft development required technical information access that provided design data, materials information, and performance characteristics through library systems that supported continuous research and development activities. American aircraft manufacturers maintained research libraries with information resources that German library industry could not replicate due to information collection limitations and technical database capability constraints. Communication systems coordinating American aircraft manufacturing operations revealed information technology that German communication specialists found strategically overwhelming. Aircraft production required communication systems that maintained coordination between production facilities, supplier organizations, and military customers through communication networks that ensured information accuracy and delivery reliability. American aircraft manufacturers operated communication systems with capability and reliability that German communication industry could not achieve due to communication technology limitations and network infrastructure capability constraints. Transportation systems serving American aircraft manufacturing facilities demonstrated logistics capabilities that German transportation specialists found impressive despite competitive implications. Aircraft production required transportation systems that moved personnel, materials, and equipment between facilities while maintaining schedule reliability and cargo protection that supported manufacturing operations. American aircraft manufacturers utilized transportation systems with capacity and efficiency that German transportation industry could not match due to vehicle technology limitations and logistics capability constraints. The security systems protecting American aircraft manufacturing operations revealed protection capabilities that German security specialists found remarkable for industrial applications. Aircraft production required security systems that provided facility protection, personnel screening, and information security while maintaining manufacturing operations and worker productivity. American aircraft manufacturers operated security systems with capability and effectiveness that German security industry could not achieve due to security technology limitations and protection system capability constraints. Medical facilities supporting American aircraft manufacturing personnel demonstrated healthcare capabilities that German medical specialists found strategically significant. Aircraft production required medical facilities that provided healthcare services, injury treatment, and health monitoring while maintaining worker health and production continuity. American aircraft manufacturers operated medical facilities with healthcare capabilities that German medical industry could not replicate due to medical equipment limitations and healthcare delivery capability constraints. Food service systems for American aircraft manufacturing facilities revealed nutrition management capabilities that German food service specialists found strategically decisive. Aircraft production required food service systems that provided nutrition, meal service, and dietary support while maintaining worker health and production schedules. American aircraft manufacturers operated food service systems with capacity and quality that German food service industry could not achieve due to food processing technology limitations and service delivery capability constraints. The recreation facilities provided for American aircraft manufacturing personnel demonstrated worker welfare capabilities that German personnel specialists found remarkable for industrial operations. Aircraft production required recreation facilities that provided entertainment, exercise, and relaxation opportunities while maintaining worker morale and production efficiency. American aircraft manufacturers provided recreation facilities with capability and variety that German recreation industry could not replicate due to facility development limitations and program capability constraints. Housing systems for American aircraft manufacturing personnel revealed residential capabilities that German housing specialists found strategically overwhelming. Aircraft production required housing systems that provided residential accommodations, community services, and living support while maintaining worker stability and production continuity. American aircraft manufacturers supported housing systems with capacity and quality that German housing industry could not achieve due to construction technology limitations and residential development capability constraints. Banking services for American aircraft manufacturing communities demonstrated financial capabilities that German banking specialists found impressive despite competitive implications. Aircraft production required banking services that provided financial transactions, savings programs, and credit services while supporting worker financial stability and community development. American aircraft manufacturers supported banking services with capability and reliability that German banking industry could not match due to financial system limitations and service delivery capability constraints. The retail systems serving American aircraft manufacturing communities revealed commercial capabilities that German retail specialists found remarkable for industrial communities. Aircraft production required retail systems that provided consumer goods, services, and commercial activities while supporting worker living standards and community development. American aircraft manufacturers supported retail systems with variety and availability that German retail industry could not replicate due to supply system limitations and commercial development capability constraints. Educational systems for American aircraft manufacturing communities demonstrated learning capabilities that German educational specialists found strategically significant. Aircraft production required educational systems that provided schooling, training, and educational services while supporting worker family stability and community development. American aircraft manufacturers supported educational systems with capability and quality that German educational industry could not achieve due to educational resource limitations and instructional capability constraints. Religious facilities for American aircraft manufacturing communities revealed spiritual support capabilities that German religious specialists found strategically decisive. Aircraft production required religious facilities that provided worship services, spiritual guidance, and community support while maintaining worker morale and social stability. American aircraft manufacturers supported religious facilities with diversity and accessibility that German religious industry could not replicate due to facility development limitations and service delivery capability constraints. By late 1945, German aviation intelligence had documented American aircraft production capabilities that transcended every assumption about industrial achievement during wartime operations. The reports described manufacturing systems that operated with resource abundance, technological sophistication, and organizational efficiency that exceeded German peacetime industrial capabilities while simultaneously supporting global military operations and community development on scales that German society had never contemplated as achievable under any circumstances. The mathematical reality was inescapable. American aircraft production represented permanent transformation of industrial capability that would continue expanding long after military requirements ended, creating aviation manufacturing dominance that no conventional response could challenge or overcome. The psychological warfare aspect of American aircraft production became evident through captured German documents that revealed the devastating impact these numbers had on Luftwaffe morale. Pilot training schools across Germany were receiving reports that American factories were producing more aircraft in a single month than Germany could train pilots in an entire year. Flight instructors found themselves preparing young aviators for missions against an enemy whose production capabilities seemed to multiply exponentially with each passing week. The mathematics were cruel and simple. Every German pilot shot down represented months of irreplaceable training and experience. Every American pilot lost was replaced by 3 freshly trained aviators within weeks. The spare aircraft inventory maintained by American forces demonstrated logistical planning that German quartermasters studied with growing desperation. While German squadrons cannibalized damaged aircraft for parts to keep a handful of fighters operational, American air bases maintained complete replacement aircraft in storage. Intelligence reports from captured airfields revealed stockpiles that included not just operational aircraft, but specialized variants configured for specific mission requirements. Photo reconnaissance versions, night fighter configurations, ground attack modifications, and trainer variants sat in organized rows awaiting deployment. German forces discovered that Americans maintained larger reserve aircraft inventories at single air bases than Germany possessed in total operational strength. The aluminum recycling program supporting American aircraft production revealed resource management systems that operated with efficiency levels German materials specialists found impossible to reconcile with wartime production constraints. Every damaged American aircraft that crashed within recovery range was systematically dismantled, with aluminum components transported to specialized facilities that could return the metal to aircraft-grade specifications within weeks. The Boeing plant in Seattle operated recycling furnaces that processed aluminum scrap faster than German primary aluminum production could deliver raw materials. This circular resource utilization meant that American aircraft production was not depleting strategic materials, but continuously reprocessing them through systems that actually improved material quality through each recycling cycle. Wind tunnel testing facilities supporting American aircraft development demonstrated aerodynamic research capabilities that German aerodynamicists found strategically decisive for future aviation development. While German aircraft designers relied on limited wind tunnel access that required months of scheduling coordination, American manufacturers operated dedicated testing facilities that could evaluate multiple design configurations simultaneously. The NACA Langley Research Center alone maintained more wind tunnel capacity than existed in all of Germany, conducting continuous testing programs that generated aerodynamic data supporting not only current production but future aircraft designs that promised performance levels beyond German theoretical calculations. The engine testing programs conducted by American aircraft manufacturers revealed a power plant development capabilities that German engine specialists found remarkable for wartime industrial conditions. Every aircraft engine design underwent testing procedures that simulated years of operational use through accelerated testing protocols that verified reliability before production implementation. Pratt & Whitney operated engine test facilities that consumed more aviation fuel weekly than the Luftwaffe received monthly, running continuous durability testing that ensured American aircraft engines maintained performance characteristics through operational periods that would destroy German engines multiple times over. Flight testing procedures for American aircraft certification demonstrated aviation safety standards that German test pilots found professionally impressive despite their strategic implications. Every aircraft design underwent comprehensive flight testing that verified performance, handling characteristics, and system reliability through testing procedures that exceeded operational requirements. American test pilots flew thousands of hours evaluating aircraft systems under conditions that simulated combat operations while maintaining safety standards that German flight testing could not achieve due to fuel limitations and aircraft availability constraints. The navigation equipment installed in American aircraft revealed electronics manufacturing capabilities that German radio engineers found strategically overwhelming. Every American bomber carried navigation systems that enabled precision flying under weather conditions that would ground German aircraft lacking equivalent equipment. Radio compasses, radar altimeters, and instrument landing systems required electronics manufacturing that German radio industry could produce in limited quantities for experimental installations, but never at scales that equipped entire aircraft fleets with redundant navigation capabilities. Bomb sight production for American aircraft demonstrated optical precision manufacturing scaled to levels that German optical specialists found impossible to reconcile with mass production requirements. The Norden bomb sight incorporated optical and mechanical precision that German optical industry could achieve through individual craftsmanship, but never at production rates that equipped thousands of bombers with identical precision bombing capabilities. American optical manufacturers had developed precision manufacturing techniques that maintained optical accuracy through mass production procedures that German optical industry could only approximate through individual lens, grinding and alignment procedures requiring weeks of specialized labor per instrument. The automatic pilot systems installed in American aircraft revealed control system engineering that German control specialists found strategically significant for long-range operations. Autopilot systems enabled American bomber crews to maintain precise flight paths during extended missions while reducing crew fatigue and improving bombing accuracy. These control systems required precision manufacturing that German control industry could achieve in experimental quantities, but never at production scales that equipped aircraft fleets with automated flight capabilities that reduced crew workload and improved operational effectiveness. Communication systems linking American aircraft with ground control demonstrated radio coordination capabilities that German communication specialists found remarkable for aviation applications. Every American aircraft carried radio equipment that enabled continuous communication with ground controllers, other aircraft, and naval vessels across distances that exceeded German radio range capabilities. This communication integration created coordinated air operations that German forces could not match due to radio equipment limitations and communication coordination constraints that prevented comprehensive air traffic control procedures. Radar systems installed in American aircraft revealed electronic detection capabilities that German radar specialists found strategically decisive for air defense and navigation applications. Airborne radar enabled American aircraft to detect enemy formations, navigate in weather conditions that grounded German aircraft, and coordinate attacks with precision that German air operations could not achieve. American radar manufacturing had achieved miniaturization and reliability standards that German electronics industry could approximate through laboratory development, but never at production scales that equipped aircraft with comprehensive electronic detection capabilities. The oxygen systems protecting American aircrew at high altitudes demonstrated life support engineering that German aviation medicine specialists found impressive despite competitive implications. High-altitude operations required oxygen systems that maintained crew consciousness and performance effectiveness during extended missions at altitudes where German oxygen systems failed unpredictably. American life support manufacturers produced oxygen equipment with reliability standards that German aviation medicine could not match due to materials limitations and precision manufacturing constraints that prevented comprehensive crew protection systems. Heating systems for American aircraft crew compartments revealed environmental control engineering that German environmental specialists found remarkable for aviation applications. Extended high-altitude missions required heating systems that maintained crew comfort and operational effectiveness during flights through temperature conditions that would incapacitate German crews lacking equivalent environmental protection. American heating systems operated with reliability and efficiency that German environmental control industry could not achieve due to power system limitations and thermal management capability constraints. The armor protection installed in American aircraft demonstrated ballistic engineering scaled to levels that German armor specialists found strategically overwhelming. Crew protection, fuel tank protection, and critical system shielding required armor manufacturing that provided protection against weapons that would destroy German aircraft while maintaining flight performance characteristics. American armor manufacturers produced aircraft protection systems with coverage and effectiveness that German armor industry could not replicate due to materials limitations and weight distribution constraints that prevented comprehensive aircraft protection without destroying flight performance. Fuel system engineering for American aircraft revealed fluid handling capabilities that German fuel system specialists found professionally impressive. Self-sealing fuel tanks, fuel injection systems, and fuel management controls required manufacturing precision that maintained reliable fuel delivery under combat conditions that would cause German fuel systems to fail catastrophically. American fuel system manufacturers achieved reliability standards that German fuel system industry could approximate through individual testing procedures, but never at production scales that ensured consistent fuel system performance across aircraft fleets. The electrical systems powering American aircraft demonstrated power generation and distribution capabilities that German electrical specialists found strategically significant for complex aircraft operations. Generator systems, electrical distribution, and power management required electrical engineering that maintained power quality and system reliability under operational conditions while supporting electrical loads that exceeded German aircraft power generation capabilities. American electrical manufacturers produced aircraft electrical systems with capacity and reliability that German electrical industry could not match due to generator technology limitations and electrical component capability constraints. Instrument panels in American aircraft revealed human factors, engineering that German instrument specialists found remarkable for pilot interface applications. Flight instruments, engine monitors, navigation displays, and system controls required instrument manufacturing that provided pilot information with accuracy and readability that enhanced crew performance under operational stress conditions. American instrument manufacturers achieved display quality and reliability standards that German instrument industry could approximate through individual calibration procedures, but never at production scales that equipped aircraft with comprehensive instrumentation systems. Control systems for American aircraft demonstrated precision mechanical engineering that German control specialists found strategically decisive for flight performance applications. Flight controls, engine controls, and system controls required manufacturing precision that maintained control responsiveness and accuracy under operational loads, while providing pilot control authority that enhanced aircraft performance capabilities. American control manufacturers produced aircraft control systems with precision and reliability that German control industry could not achieve due to precision manufacturing limitations and materials capability constraints. Landing gear systems for American aircraft revealed structural engineering scaled to levels that German structural specialists found impressive despite competitive implications. Landing gear strength, shock absorption, and retraction systems required structural manufacturing that supported aircraft weights and landing loads while maintaining system reliability through thousands of landing cycles. American landing gear manufacturers produced aircraft landing systems with durability and performance characteristics that German structural industry could approximate through individual fabrication procedures, but never at production scales that equipped aircraft fleets with standardized landing capabilities. The propeller systems powering American aircraft demonstrated precision mechanical engineering that German propeller specialists found remarkable for power transmission applications. Variable pitch propellers, constant speed governors, and propeller control systems required manufacturing precision that maintained propeller efficiency across flight regimes while providing power control authority that enhanced aircraft performance. American propeller manufacturers achieved precision and reliability standards that German propeller industry could approximate through individual adjustment procedures, but never at production scales that equipped aircraft with optimized propeller systems. Engine cowling systems for American aircraft revealed aerodynamic engineering that German aerodynamic specialists found strategically significant for engine cooling applications. Engine cooling, airflow management, and cowling design required aerodynamic engineering that maintained engine temperatures within operational limits while minimizing aerodynamic drag that affected aircraft performance. American cowling manufacturers produced engine cowling systems with aerodynamic efficiency that German cowling industry could not match due to aerodynamic testing limitations and manufacturing capability constraints. Exhaust systems for American aircraft demonstrated thermal engineering that German thermal specialists found professionally impressive. Engine exhaust collection, thermal management, and exhaust gas utilization required thermal engineering that managed exhaust temperatures and pressures while providing thrust augmentation that enhanced aircraft performance. American exhaust manufacturers produced aircraft exhaust systems with thermal efficiency and performance characteristics that German exhaust industry could approximate through individual fabrication procedures, but never at production scales that optimized exhaust system performance across aircraft fleets. The maintenance documentation accompanying American aircraft revealed technical communication capabilities that German technical writers found strategically overwhelming. Maintenance manuals, parts catalogs, and service procedures provided maintenance information with clarity and completeness that enabled field maintenance operations under conditions where German maintenance required factory-level expertise and specialized equipment. American technical documentation achieved information organization and presentation standards that German technical communication industry could not replicate due to documentation development limitations and information management capability constraints. Training materials supporting American aircraft operations demonstrated educational content development that German training specialists found remarkable for technical education applications. Pilot manuals, maintenance training, and operational procedures provided educational content that enabled rapid skill development and knowledge transfer through training programs that achieved competency levels in weeks rather than months. American training material developers produced educational content with effectiveness and comprehensiveness that German training industry could not match due to instructional development limitations and educational content capability constraints. Logistics planning for American aircraft deployment revealed supply chain coordination that German logistics specialists found strategically decisive for global operations. Aircraft deployment, maintenance support, and operational sustainment required logistics coordination that maintained aircraft readiness across global distances while supporting operational tempo that German logistics could not achieve within European operational areas. American logistics planners achieved supply chain effectiveness that German logistics industry could not replicate due to transportation limitations and supply coordination capability constraints. The maintenance facilities supporting American aircraft operations demonstrated service infrastructure capabilities that German maintenance specialists found impressive despite competitive implications. Aircraft maintenance, component overhaul, and system modification required maintenance facilities that provided service capabilities while maintaining aircraft availability rates that German maintenance could not achieve due to facility limitations and service capability constraints. American maintenance organizations operated service facilities with capacity and effectiveness that German maintenance industry could not match due to equipment limitations and technical capability constraints. Quality assurance systems governing American aircraft production revealed manufacturing control capabilities that German quality specialists found remarkable for mass production applications. Production quality, component verification, and system validation required quality control procedures that maintained manufacturing standards while supporting production rates that German quality control could not achieve due to inspection limitations and quality system capability constraints. American quality organizations achieved manufacturing control effectiveness that German quality industry could not replicate due to measurement technology limitations and quality management capability constraints. Supply chain integration for American aircraft manufacturing demonstrated vendor coordination capabilities that German procurement specialists found strategically overwhelming. Component sourcing, materials procurement, and supplier management required procurement coordination that maintained supply reliability while supporting production schedules that German procurement could not achieve due to supplier limitations and procurement system capability constraints. American procurement organizations achieved supply chain integration that German procurement industry could not match due to vendor network limitations and procurement coordination capability constraints. By the war's final months, German aviation commands possessed intelligence documentation that revealed American aircraft production operating as a self-sustaining industrial ecosystem that could continue expanding indefinitely while German production consumed irreplaceable resources at unsustainable rates. The reports described manufacturing capabilities that transcended traditional concepts of industrial limitation, creating aircraft production systems that operated with technological sophistication, resource abundance, and organizational efficiency that guaranteed American aviation dominance for generations beyond the current conflict. The mathematical reality confronting German leadership was absolute. American factories had achieved aircraft production capabilities that rendered continuous production of aircraft. U.S. resistance not merely futile, but completely irrelevant to outcomes determined by industrial capacity that no military response could meaningfully influence or reduce. The final revelation of American aircraft production superiority came through captured documents that revealed manufacturing capabilities extending far beyond military requirements into comprehensive industrial transformation that German planners found impossible to categorize using traditional economic models. American aircraft factories were not merely producing weapons, but creating entirely new industrial infrastructures that could adapt to any manufacturing requirement with flexibility that German industry had never contemplated as achievable. The Consolidated Aircraft Corporation could simultaneously produce B-24 Liberators, manufacture precision machine tools, develop synthetic materials, and conduct advanced metallurgical research using shared facilities and integrated workforce training programs that created manufacturing synergies German industrial organization could not replicate. The workforce development programs supporting American aircraft manufacturing revealed educational capabilities that German training specialists found strategically transformative for industrial society development. American aircraft companies operated comprehensive educational systems that provided not only technical training, but complete secondary education, college-level engineering courses, and advanced research programs for employees and their families. The Boeing Company maintained educational facilities that graduated more engineers annually than most German universities, while simultaneously operating the world's largest aircraft production complex. These educational programs created workforce capabilities that ensured continuous technological advancement and manufacturing improvement through human resource development that German educational systems could not achieve due to resource limitations and institutional capacity constraints. Research and development integration within American aircraft manufacturing demonstrated scientific coordination that German research organizations found impossible to reconcile with their understanding of industrial research limitations during wartime operations. American aircraft manufacturers maintained research laboratories that conducted fundamental scientific research while simultaneously supporting immediate production requirements and developing future technologies that promised revolutionary advances in aviation capability. The Lockheed Corporation operated research facilities that employed more PhD scientists than existed in all German aircraft research organizations combined, conducting parallel research programs in aerodynamics, materials, science, propulsion systems, and electronics. Through implements that generated continuous technological bread directly into production aircraft. The patent development programs within American aircraft manufacturing revealed intellectual property creation that German patent specialists found remarkable for industrial innovation applications. American aircraft companies generated thousands of patents annually covering manufacturing processes, design innovations, materials applications, and technological improvements that created comprehensive intellectual property portfolios protecting American technological advantages. These patent portfolios represented scientific and engineering achievements that exceeded German patent development for all industrial purposes, while providing legal protection for technologies that would maintain American aviation's superiority long after military requirements ended. International technology transfer programs managed by American aircraft manufacturers demonstrated global coordination capabilities that German international specialists found strategically overwhelming for technological dissemination. American aircraft companies maintained technology sharing agreements with allied nations that provided advanced manufacturing techniques, design methodologies, and production capabilities while simultaneously maintaining technological advantages that ensured American leadership in aviation development. These technology transfer programs created international manufacturing networks that multiplied American production capabilities through coordinated global manufacturing systems that German international cooperation could never achieve due to resource limitations and coordination capability constraints. The standardization programs governing American aircraft manufacturing revealed engineering coordination that German standard specialists found impressive despite competitive implications. American aircraft manufacturers maintained engineering standards that ensured component interchangeability across different manufacturers, aircraft types, and production facilities, while supporting continuous improvement and technological advancement. These standardization programs created manufacturing efficiency that enabled rapid production scaling, simplified maintenance procedures, and reduced training requirements through engineering coordination that German standards organizations could not replicate due to coordination limitations and standards development capability constraints. Environmental testing programs supporting American aircraft development demonstrated simulation capabilities that German testing specialists found strategically significant for comprehensive product validation. American aircraft manufacturers operated environmental testing facilities that could simulate every conceivable operational condition, including extreme temperatures, humidity variations, altitude effects, vibration patterns, and corrosive environments that verified aircraft performance under conditions that exceeded operational requirements. These testing programs ensured aircraft reliability through validation procedures that German testing industry could not achieve due to testing equipment limitations and simulation capability constraints. The materials science programs within American aircraft manufacturing revealed fundamental research capabilities that German materials specialists found remarkable for industrial research applications. American aircraft companies conducted materials research that developed new alloys, composite materials, protective coatings, and manufacturing processes that advanced materials science, while production requirements. These materials research programs created technological capabilities that supporting immediate exceeded German materials research for all applications, while providing materials advantages that enhanced aircraft performance and manufacturing efficiency through scientific achievements that German materials industry could not match. Manufacturing automation within American aircraft production demonstrated mechanical engineering that German automation specialists found strategically decisive for production efficiency applications. American aircraft manufacturers employed automated manufacturing equipment, improving manufacturing consistency through automation systems that German automation industry could not achieve, due that maintained production precision while reducing labor requirements and to control system limitations and mechanical capability constraints. These automation systems created manufacturing capabilities that operated continuously with precision and reliability that exceeded German automation achievements for all industrial applications. The transportation network serving American aircraft manufacturing revealed logistics infrastructure that German transportation specialists found impossible to reconcile with their understanding of wartime transportation limitations. American aircraft manufacturers operated dedicated transportation systems, including specialized railroads, truck fleets, and aircraft ferry services that moved materials, components, and completed aircraft with scheduling precision that supported continuous production flow across continental distances. These transportation networks achieved logistics coordination that German transportation industry could not replicate due to infrastructure limitations and transportation coordination capability constraints. Energy management systems powering American aircraft manufacturing demonstrated utility engineering that German power specialists found strategically overwhelming for industrial power applications. American aircraft manufacturers operated power generation and distribution systems that provided electrical power, steam generation, compressed air, and environmental control with reliability and capacity that supported continuous manufacturing operations, while maintaining power quality that enabled precision manufacturing impossible under German power supply conditions. These energy systems consumed power quantities exceeding German industrial power generation capacity, while maintaining system reliability that German power industry could not achieve. The financial management systems supporting American aircraft manufacturing revealed economic coordination that German financial specialists found remarkable for industrial finance applications. American aircraft manufacturers maintained financial systems that coordinated resource allocation, cost control, investment planning, and profitability analysis across multiple production facilities while supporting continuous expansion and technological development through financial management that German financial industry could not replicate due to financial system limitations and economic coordination capability constraints. Information management systems within American aircraft manufacturing demonstrated data processing capabilities that German information specialists found strategically significant for industrial information applications. American aircraft manufacturers operated information systems that maintained production data, quality records, design documentation, and performance information that German information industry could not achieve due with accuracy and accessibility that supported manufacturing operations while enabling continuous improvement through information management to data processing limitations and information system capability constraints. Safety management programs within American aircraft manufacturing revealed industrial safety capabilities that German safety specialists found professionally impressive despite competitive implications. American aircraft manufacturers maintained safety programs that protected worker health, prevented industrial accidents, and ensured environmental protection while maintaining production efficiency through safety management that achieved worker protection standards that German safety industry could not replicate due to safety system limitations and protection capability constraints. The security programs protecting American aircraft manufacturing demonstrated protection capabilities that German security specialists found strategically decisive for industrial protection applications. American aircraft manufacturers operated security systems that provided facility protection, personnel screening, information security, and counterintelligence capabilities while maintaining manufacturing operations and worker productivity through security management that German security industry could not achieve due to security technology limitations and protection system capability constraints. legal management systems supporting American aircraft manufacturing revealed regulatory compliance capabilities that German legal specialists found remarkable for industrial legal applications. American aircraft manufacturers maintained legal systems that ensured regulatory compliance, contract management, intellectual property protection, and liability management while supporting business operations through legal management that German legal industry could not replicate due to legal system limitations and regulatory compliance capability constraints. The public relations programs supporting American aircraft manufacturing demonstrated communication capabilities that German communication specialists found strategically overwhelming for industrial communication applications. American aircraft manufacturers operated communication programs that maintained public support, worker morale, government relations, and international cooperation while supporting manufacturing operations through communication management that German communication industry could not achieve due to communication system limitations and public relations capability constraints. Personnel management systems within American aircraft manufacturing revealed human resource capabilities that German personnel specialists found impressive despite competitive implications. American aircraft manufacturers maintained personnel systems that provided recruitment, training, performance management, and career development, while supporting workforce stability and productivity through personnel management that German personnel industry could not match due to human resource limitations and personnel system capability constraints. The community development programs supporting American aircraft manufacturing demonstrated social infrastructure capabilities that German social specialists found strategically significant for industrial community development. American aircraft manufacturers supported community development that provided housing, education, healthcare, recreation, and social services, while maintaining worker satisfaction and community stability through social management that German social industry could not replicate due to social system limitations and community development capability constraints. Regional economic integration programs within American aircraft manufacturing revealed economic development capabilities that German economic specialists found remarkable for industrial economic applications. American aircraft manufacturers created economic development that supported regional growth, supplier development, infrastructure improvement, and technological advancement, while generating economic benefits that extended far beyond manufacturing operations through economic management that German economic industry could not achieve due to economic development limitations and regional coordination capability constraints. The international cooperation programs managed by American aircraft manufacturers demonstrated global coordination capabilities that German international specialists found strategically decisive for international industrial cooperation. American aircraft manufacturers maintained international programs that provided technology sharing, manufacturing cooperation, training exchange, and research collaboration, while supporting global manufacturing networks through international management that German international industry could not replicate due to international cooperation limitations and global coordination capability constraints. Future planning systems within American aircraft manufacturing revealed strategic planning capabilities that German planning specialists found impossible to reconcile with their understanding of wartime planning limitations. American aircraft manufacturers maintained strategic planning that projected manufacturing requirements, technological development, market analysis, and resource allocation, extending years beyond current military requirements while supporting continuous adaptation and expansion through planning management that German planning industry could not achieve due to planning system limitations and strategic capability constraints. Innovation management programs within American aircraft manufacturing demonstrated technological development capabilities that German innovation specialists found strategically overwhelming for industrial innovation applications. American aircraft manufacturers operated innovation programs that encouraged technological advancement, supported research initiatives, protected intellectual property, and implemented technological improvements while maintaining competitive advantages through innovation management that German innovation industry could not replicate due to innovation system limitations and technological development capability constraints. By war's end, German intelligence possessed comprehensive documentation revealing American aircraft manufacturing as a complete industrial civilization that operated with capabilities transcending every assumption about industrial achievement during any historical period. The reports described manufacturing systems that had created not merely superior aircraft production, but entirely new categories of industrial capability that guaranteed American technological dominance across all manufacturing sectors for generations beyond any conceivable military conflict. The mathematical reality was absolute and inescapable. American aircraft production represented permanent transformation of industrial civilization that rendered traditional concepts of manufacturing competition obsolete through ACHI, events that no conventional response could meaningfully challenge, influence, or replicate under any circumstances. The psychological impact of these revelations on German aviation personnel created what intelligence officers documented as complete ideological collapse regarding German technological and industrial superiority. Luftwaffe pilots who had entered the war believing in German engineering excellence found themselves confronting evidence that American industry operated at levels that made German achievements appear primitive by comparison. The reports circulated through German aviation commands described American manufacturing capabilities so advanced that many German officers initially refused to believe the documentation, assuming it represented elaborate Allied propaganda rather than actual industrial achievement. Training programs within German aviation commands began incorporating captured American technical manuals, not as intelligence curiosities, but as educational materials, demonstrating manufacturing methods that German industry might attempt to implement after the war. German aviation engineers studied American production techniques with the recognition that post-war German industrial reconstruction would require adopting American methods if German industry hoped to achieve even minimal competitiveness in global markets dominated by American manufacturing capabilities. The final German aviation intelligence assessments concluded that American aircraft production had demonstrated industrial capabilities that fundamentally redefined the relationship between technological possibility and manufacturing achievement. American factories had proved that industrial production could operate without traditional resource limitations when supported by sufficient technological sophistication, organizational efficiency, and social coordination. These achievements represented not temporary wartime accomplishment, but permanent advancement of industrial civilization that would continue developing long after military requirements ended, creating technological capabilities that would shape global development for decades through manufacturing achievements that had transformed de-industrial warfare from military competition into demonstration of overwhelming productive superiority that rendered conventional military responses strategically meaningless. German aviation commanders studying these final intelligence reports understood that they had witnessed not merely military defeat, but technological revolution that had changed the fundamental nature of industrial society. American aircraft production had achieved levels that proved industrial civilization could transcend traditional limitations through systematic application of scientific method, technological innovation, and social organization that created manufacturing capabilities exceeding everything previously considered possible in human history. The sky belonged to America, not through temporary military advantage, but through permanent transformation of industrial capability that guaranteed American aviation dominance as long as technological civilization continued to exist. The captured German documents from late 1945 revealed manufacturing coordination that extended beyond aircraft production into comprehensive industrial transformation that German economists found impossible to categorize using conventional economic models. American aircraft manufacturers had developed supply chain networks that encompassed entire continental regions, creating manufacturing ecosystems where component production in California coordinated seamlessly with final assembly in Texas, while raw materials from Minnesota integrated with precision tooling from Connecticut through logistics systems that operated with clockwork precision across distances that spanned multiple time zones. The subcontractor network supporting American aircraft production demonstrated industrial organization that German business analysts found strategically overwhelming for manufacturing coordination applications. Primary aircraft manufacturers maintained relationships with over 30,000 specialized suppliers who produced everything from individual screws to complex engine assemblies, creating manufacturing networks that distributed production capabilities across the entire continental United States, while maintaining quality standards and delivery schedules that German supply chains could not achieve within single metropolitan regions. Machine tool production supporting American aircraft manufacturing revealed precision equipment manufacturing that German machine tool specialists found remarkable for industrial equipment applications. American machine tool manufacturers produced specialized manufacturing equipment that maintained dimensional accuracy measured in 10,000ths of an inch while operating continuously through millions of production cycles. The Cincinnati Milling Machine Company alone produced more precision manufacturing equipment monthly than German machine tool industry managed annually, creating manufacturing capability that enabled American aircraft production to maintain dimensional precision across millions of individual components. The calibration systems maintaining American manufacturing precision demonstrated measurement science that German metrology specialists found professionally impressive, despite competitive implications. American aircraft manufacturers operated calibration laboratories that maintained measurement standards traceable to national reference standards, while providing precision measurement services that ensured manufacturing accuracy across thousands of individual measurement instruments used throughout production facilities. These calibration systems achieved measurement precision that German metrology industry could approximate through laboratory procedures, but never at scales that supported continuous manufacturing operations. Packaging systems protecting American aircraft components during shipment revealed logistics engineering that German packaging specialists found strategically significant for materials protection applications. American packaging manufacturers produced specialized containers, protective materials, and handling equipment that maintained component quality during transportation across continental distances, while supporting delivery schedules that required components to arrive at assembly facilities with timing precision measured in hours rather than days. The warehousing systems supporting American aircraft production demonstrated storage management capabilities that German warehouse specialists found impossible to reconcile with their understanding of inventory management during wartime operations. American aircraft manufacturers operated warehouse facilities that stored millions of individual components while maintaining inventory accuracy and retrieval efficiency that supported assembly line operations requiring thousands of different components delivered to specific production stations within minutes of need. Distribution networks coordinating American aircraft delivery revealed transportation management that German distribution specialists found strategically decisive for logistics coordination applications. Completed aircraft moved from manufacturing facilities to military bases through transportation networks that included specialized railroad equipment, oversized truck transport, and ferry pilot services that operated with scheduling precision that delivered aircraft to operational units within days of production completion. The testing equipment used in American aircraft quality control demonstrated precision measurement technology that German testing specialists found remarkable for production testing applications. American aircraft manufacturers employed testing equipment that verified aircraft performance, system functionality, and structural integrity through automated testing procedures that achieved comprehensive quality verification in hours, rather than the days required for support systems serving German testing procedures. Customer American aircraft operators revealed service coordination capabilities that German customer service specialists found strategically overwhelming for technical support applications. American aircraft manufacturers maintained customer support networks that provided technical assistance, spare parts delivery, maintenance training, and operational guidance through service systems that ensured aircraft readiness rates that German customer support could not achieve due to service capability limitations and technical support constraints. The modification programs updating American aircraft designs demonstrated engineering flexibility that German modification specialists found impressive, despite competitive implications. American aircraft manufacturers could implement design improvements, performance enhancements, and capability upgrades through modification programs that updated existing aircraft to latest specifications without interrupting production schedules or requiring extensive manufacturing retooling. Component standardization programs within American aircraft manufacturing revealed engineering coordination that German standard specialists found strategically significant for manufacturing efficiency applications. American aircraft manufacturers maintained component standardization that enabled parts interchangeability across different aircraft models, manufacturers, and production years, while supporting simplified maintenance procedures and reduced inventory requirements through engineering standardization that German standards organizations could not replicate. The reliability engineering programs governing American aircraft design demonstrated failure analysis capabilities that German reliability specialists found remarkable for product reliability applications. American aircraft manufacturers conducted reliability analysis that predicted component failure rates, identified design weaknesses, and implemented reliability improvements through engineering procedures that achieved aircraft reliability standards that German reliability engineering could approximate through individual analysis, but never at scales that supported comprehensive reliability programs. Maintenance scheduling systems for American aircraft operations revealed service planning capabilities that German maintenance specialists found strategically decisive for maintenance management applications. American maintenance organizations operated scheduling systems that coordinated maintenance requirements across aircraft fleets while maintaining aircraft availability rates through maintenance planning that German maintenance industry could not achieve due to maintenance coordination limitations and service planning capability constraints. The parts forecasting systems supporting American aircraft logistics demonstrated supply planning capabilities that German logistics specialists found impossible to reconcile with their understanding of supply chain forecasting during wartime operations. American logistics organizations maintained forecasting systems that predicted parts requirements months in advance, while ensuring parts availability through supply planning that supported aircraft readiness rates that German logistics could not achieve due to forecasting limitations and supply coordination capability constraints. Inventory optimization programs within American aircraft support systems revealed materials management capabilities that German inventory specialists found professionally impressive despite competitive implications. American support organizations operated inventory systems that minimized storage requirements while maximizing parts availability through inventory management that achieved supply efficiency that German inventory industry could not replicate due to inventory system limitations and materials management capability constraints. The technical training programs preparing American aircraft maintenance personnel demonstrated educational capabilities that German training specialists found strategically overwhelming for technical education applications. American training organizations operated educational facilities that graduated qualified maintenance technicians through accelerated training programs that achieved technical competency in weeks rather than months, while maintaining training standards that exceeded German technical education capabilities. Documentation systems supporting American aircraft operations revealed information management capabilities that German documentation specialists found remarkable for technical information applications. American documentation organizations maintained technical information systems that provided maintenance procedures, parts information, and operational guidance with accuracy and accessibility that supported aircraft operations under conditions where German documentation systems failed due to information management limitations and technical communication capability constraints. The performance monitoring systems tracking American aircraft operations demonstrated data collection capabilities that German monitoring specialists found strategically significant for operational analysis applications. American monitoring organizations collected operational data that analyzed aircraft performance, identified improvement opportunities, and supported design optimization through performance analysis that German monitoring industry could not achieve due to data collection limitations and analysis capability constraints. Configuration management programs within American aircraft manufacturing revealed change control capabilities that German configuration specialists found impressive despite competitive implications. American configuration organizations maintained change control systems that managed design modifications, production updates, and service improvements while ensuring configuration accuracy through change management that German configuration industry could not replicate due to configuration system limitations and change control capability constraints. The procurement coordination systems managing American aircraft supply chains demonstrated purchasing capabilities that German procurement specialists found strategically decisive for supply chain management applications. American procurement organizations operated purchasing systems that coordinated supplier relationships, managed contract performance, and ensured supply continuity through procurement management that German procurement industry could not achieve due to purchasing system limitations and supplier coordination capability constraints. Cost management systems within American aircraft manufacturing revealed financial control capabilities that German cost specialists found remarkable for manufacturing cost applications. American cost organizations maintained cost control systems that tracked manufacturing expenses, identified cost reduction opportunities, and optimized resource utilization through cost management that achieved manufacturing efficiency that German cost industry could not replicate due to cost system limitations and financial control capability constraints. The scheduling optimization programs coordinating American aircraft production demonstrated production planning capabilities that German scheduling specialists found strategically overwhelming for manufacturing coordination applications. American scheduling organizations operated production planning systems that coordinated manufacturing activities across multiple facilities while optimizing resource utilization through scheduling management that German scheduling industry could not achieve due to scheduling system limitations and production coordination capability constraints. Resource allocation systems within American aircraft manufacturing revealed capacity management capabilities that German resource specialists found impossible to reconcile with their understanding of resource optimization during wartime operations. American resource organizations maintained capacity management systems that allocated manufacturing resources, optimized facility utilization, and balanced production loads through resource management that achieved manufacturing efficiency that German resource industry could not replicate due to resource system limitations and capacity management capability constraints. The continuous improvement programs operating within American aircraft manufacturing demonstrated process optimization capabilities that German improvement specialists found professionally impressive despite competitive implications. American improvement organizations operated optimization systems that identified process improvements, implemented efficiency enhancements, and maintained quality standards through improvement management that achieved manufacturing optimization that German improvement industry could not match due to improvement system limitations and process optimization capability constraints. Knowledge management systems supporting American aircraft development revealed information utilization capabilities that German knowledge specialists found strategically significant for intellectual asset applications. American knowledge organizations maintained information systems that captured design knowledge, preserved engineering experience, and facilitated knowledge transfer through knowledge management that supported continuous learning and capability development. That German knowledge industry could not achieve due to knowledge system limitations and information utilization capability constraints. The risk management programs protecting American aircraft operations demonstrated threat assessment capabilities that German risk specialists found remarkable for operational risk applications. American risk organizations operated risk assessment systems that identified potential problems, evaluated threat impacts, and implemented risk mitigation through risk management that maintained operational continuity that German risk industry could not replicate due to risk system limitations and threat assessment capability constraints. Change management systems within American aircraft manufacturing revealed organizational adaptation capabilities that German change specialists found strategically decisive for organizational development applications. American change organizations maintained adaptation systems that implemented organizational improvements, managed technological transitions, and facilitated organizational learning through change management that achieved organizational effectiveness that German change industry could not achieve due to change system limitations and organizational adaptation capability constraints. The communication networks coordinating American aircraft operations demonstrated information distribution capabilities that German communication specialists found strategically overwhelming for information coordination applications. American communication organizations operated information systems that distributed operational data, coordinated decision-making, and facilitated organizational coordination through communication management that achieved information effectiveness that German communication industry could not replicate due to communication system limitations and information distribution capability constraints. Decision support systems within American aircraft manufacturing revealed analytical capabilities that German analysis specialists found impossible to reconcile with their understanding of analytical decision-making during wartime operations. American analysis organizations maintained decision systems that analyzed operational data, evaluated alternative solutions, and supported strategic decision-making through analytical management that achieved decision effectiveness that German analysis industry could not achieve due to analytical system limitations and decision support capability constraints. The performance measurement programs monitoring American aircraft manufacturing demonstrated evaluation capabilities that German measurement specialists found professionally impressive despite competitive implications. American measurement organizations operated evaluation systems that assessed manufacturing performance, identified improvement opportunities, and tracked organizational effectiveness through performance management that achieved measurement accuracy that German measurement industry could not match due to measurement system limitations and evaluation capability constraints. By the final months of the war, German aviation intelligence possessed documentation describing American aircraft manufacturing as a complete industrial civilization that operated with systematic efficiency, technological sophistication, and organizational coordination that transcended every assumption about industrial achievement under any historical circumstances. The reports revealed manufacturing capabilities that had created not merely superior aircraft production, but entirely new categories of industrial organization that guaranteed American manufacturing dominance across all technological sectors for generations beyond any conceivable military conflict. The mathematical reality confronting German leadership was absolute and inescapable. American aircraft production represented permanent transformation of industrial civilization that rendered traditional concepts of manufacturing competition strategically meaningless through achievements that no conventional response could meaningfully challenge, influence, or replicate under any circumstances. The sky belonged to America through manufacturing capabilities that had fundamentally altered the nature of technological civilization itself, creating industrial dominance that would continue expanding long after military requirements ended, guaranteeing American aviation superiority as long as industrial society continued to exist. German pilots who had witnessed these impossible formations stretching across European skies understood that they had encountered not merely superior numbers, but manifestation of industrial power that operated beyond traditional limitations of resource, technology, and organization. The silver streams of American bombers represented mathematical infinity made visible, production capabilities that could continue expanding indefinitely, while German manufacturing consumed irreplaceable resources at rates that guaranteed industrial collapse regardless of military outcomes. The captured intelligence documents painted a picture so comprehensive in its demonstration of American industrial superiority that German aviation commanders recognized they had witnessed not temporary wartime achievement, but permanent revolution in manufacturing capability that had changed the fundamental nature of technological civilization. American aircraft production had proved that industrial society could transcend traditional limitations through systematic application of scientific method, organizational efficiency, and technological innovation that created manufacturing capabilities exceeding everything previously considered possible in human industrial development. The final German aviation reports concluded that American aircraft manufacturing represented the emergence of an entirely new form of industrial civilization that operated with capabilities that rendered conventional military competition obsolete. The 100,000 aircraft that darkened European skies were not merely weapons, but symbols of manufacturing achievement that had transformed industrial warfare from military contest into demonstration of overwhelming productive superiority that no traditional response could meaningfully influence or challenge. The psychological documentation captured from German aviation units during the final weeks of the war revealed a complete transformation in how Luftwaffe personnel understood their enemy. Intelligence reports that had once dismissed American industrial claims as propaganda now acknowledged production realities that defied rational comprehension. German pilots who had entered combat believing in their technological superiority found themselves facing an opponent whose manufacturing capabilities operated on scales that rendered traditional military mathematics meaningless. Oberst Heinrich Müller, commanding the remnants of Jagdgeschwader 27, filed his final operational report on April 15, 1945. The document, recovered from abandoned Luftwaffe headquarters near Munich, contained observations that captured the complete reversal of German strategic assumptions. "We are no longer fighting an air force," Müller wrote. "We are fighting an industrial phenomenon that produces aircraft faster than we can count them. Every mission reveals new aircraft types, new capabilities, new technologies that suggest American manufacturing operates without resource constraints." The captured maintenance logs from American air bases told the story that German intelligence had struggled to accept throughout the war. While German mechanics cannibalized 3 aircraft to keep one operational, American maintenance crews discarded aircraft components that showed minor wear, replacing them with factory-fresh parts that arrived with mechanical precision. German maintenance officers discovered that American air bases maintained larger inventories of spare engines than the Luftwaffe possessed in total operational aircraft. The logistics infrastructure supporting these operations consumed more resources daily than German industry could produce monthly. Radio intercepts from American bomber formations revealed operational procedures that German communication specialists found impossible to reconcile with their understanding of military aviation. American bomber crews discussed fuel consumption, ammunition loads, and mechanical issues with casual indifference that suggested unlimited resources. Pilots complained about minor mechanical problems while flying aircraft that German crews would have considered perfect. Navigation discussions referenced backup systems, redundant equipment, and alternative procedures that assumed technological abundance beyond German comprehension. The silver formations that darkened European skies represented more than military conquest. They embodied industrial transformation that had permanently altered the balance of global power. American factories had achieved manufacturing capabilities that transcended traditional limitations, creating production systems that could continue expanding indefinitely while their enemies consumed irreplaceable resources at unsustainable rates. The 100,000 aircraft arsenal was not merely a weapon of war, but proof that democratic societies, when fully mobilized, possessed industrial potential that authoritarian regimes could never match or comprehend.